Okay. So, everyone's thrilled and excited to be back in math class. Yay. Liars. Yeah, okay. All right. Okay. I think I got it. One or two more people that are missing. All right. So, what I wanted to do today was remind you of this thing called math, that we occasionally do here. And I kind of wanted us to just spend a little bit of time reviewing conditional probabilities and all other such related mathematical concepts. All right. Let me get my notes. All right. So, conditional probabilities. Okay, first of all, when we're dealing with conditional probabilities, we're dealing with dependent events. Okay, a dependent event is when the probability of A happening given that B has already happened. So let's think about this one more time. This is what this is really saying. Okay, B happened. Okay, that's what's going on. By the way, my camera seems to be a little fuzzy. Is that fuzzy or is it just me? By the way, my computer completely died. I mean, like, we're not just talking died. We're talking like dead as Julius Caesar. Okay. Like, I had an electrician come in to do some wiring in my garage, and he just goes over to the breaker box and just starts flipping stuff. And one of them was the office, and it fried my computer, like dead, like a piece of fried liver, dead. And it not only destroyed my computer, it destroyed my power supply, and then proceeded to destroy both of my hard drives, which means that all of the work I did last year, all of it, is gone. Oh, good question. Did I pay him? He has not yet sent me a bill. But the problem is that it's like he did work for me. He did a lot of work for me. So it's going to be an expensive bill. But it cost me about $450 to repair and replace all of the parts in my computer. So we're going to have a little chat. Okay, now. Okay, dependent events, think about it this way. B happened already, okay? Sorry, wait a second, time out. Okay, if things are independent, this is true. I want to say this. Independent events. So when you are independent, who cares? Wow, I'm really good. Not enough coffee today. If they're independent, it doesn't matter if B happened already anyway, okay? So for example, let's say I flip a coin and roll a die, okay? Those are independent. But if I say, for example, I pulled a red card out of the deck and I laid it over here, and then I pulled another red card. You see, because I took one card out, the second event has different odds. Now, if they are dependent events, the probability of both of them happening all over the probability of B happening. Okay. All right. So let's talk about some examples. I just want to make sure that everybody knows what the heck is going on in here. All right. All right. Beautiful. Now, okay. All right, let's do this. We're gonna do this with real live data. In the chat, or how about this? In the participants list, go into the participants list, and do you have a yes, no, green check, red X? Do you have that? Okay. Give me a green check if you have an Apple phone. And give me a red X if you have Samsung. Do it one more time because it went ahead and took them all down. I'm gonna see if I can get that fixed. One more time. Everybody, I need everybody to vote again. Why am I not seeing? Okay. So I'm seeing 8 Apple, 2 Samsung. Okay. Now, I'm going to tell you that the probability of an Apple phone breaking is, let's say, 5%. And a Samsung, let's say the probability of that one breaking is 10%. Okay. Well, guys, I mean, really, like, mine, whatever. So I can't really help you on that one. Now, let's do this. If I pick a random person out of this class, what is the probability that I've picked an Apple user?
80%.
Okay, so 0.8. And Samsung is 2 out of 10, so 0.2. And that's good to know because these both add up to 1, which is 100%, which is kind of a good internal check. All right, now, of the Apple users, 5% of them are broken. That means that 95% are not broken. And of my Samsung people, this is of all Samsung users, there is a 10% chance of a broken one and a 90% chance of a not broken one. Okay. So here's the question. Here's kind of like the big takeaway, big idea question in this. I pick a student what is, I'm not going to use odds, I'll use probability. What is the probability that it is an apple given that it is broken. So I picked a kid, said, turn on your phone, and that student says to me, snap, it's broken. What are the odds that he or she is looking at an Apple phone? Okay. So the way to do this is to say to yourself, first, I mean, it's kind of like the long way of doing it. You don't have to always do it this way, but this works. Okay. Go ahead and figure out what are the odds for each one of these four situations. So 0.8 times 0.05, 0.8 times 0.95, so on and so forth. So this is 0.04. This is 19 out of 20. So 2 out of 5, so 18. Oh, dang, brain damage. 76%. This is 0.2. And okay. Okay. Does everyone understand how I came up with those numbers?
Yes.
Okay. Now, one thing just to kind of like double check yourself to make sure that you're not like totally out of your mind. Take a look at those two. If I added them up, it would be 80%. And if I added them up, I would have 20%. And if I added all of these up, I should get 100%. Okay. So we're all good. Now, let's answer the question. What is the probability that it's an apple and it's broken? So let's think about this. I need the probability of an apple given that it's broken. So that means I need to find out what is the probability of a broken apple divided by all of the broken phones. So apple and broken would be this guy.
Wait, isn't that the not broken?
Oh, is that not broken? Oh, apple and broken. Yeah, sorry. Good call. Thank you. Yeah, I did not have my coffee this morning. You can probably tell. And all of the brokens, okay? So that means I'm dealing with this and this. Or if I was saying strictly what's the probability, then you would just say 0.6. So if you think about it, now I just did this with a class of 10 kids, but let's say I worked at a phone repair shop, okay? And I have a pile of broken phones. Well, if you think about it, there's going to be some of those phones are going to be Apples and some of those phones are going to be Samsungs. And the idea is that of the pile of the broken phones, 2/3 of them are dead apples. Okay. Does that make sense at all? How about a scale of 1 to 5?
Yes.
Give it to me in the private chat. Scale of 1 to 5. All right. Okay. Okay. Let's avoid that one. Okay. So we have a box labeled A that has 8 cards numbered 1 through 8. And we have a box B, and that one contains 5 cards. All right. A box is picked at random. And a card is selected. Find the probability that the card came from. Find the probability that the card came from box A, given that it's even. Or even numbered. So do yourself a favor. Build a tree. I'll give you a few minutes to chew on this one before I dive into it. Okay. Gotten one right answer. Okay, so let's do this thing. Well, I've only got 2 boxes, and there's no difference between the boxes really. I mean, you know, so the probability of A and B's, picking A and picking B, is 1/2 and 1/2. Okay. Now, if I'm in box A, what are the odds, or what are the odds that it's even? Well, I've got 1, 2, 3, 4 out of 8, and 4 out of 8 for odd or not even. Okay. Now for box B, I've only got 2 out of 5 and 3 out of 5. Okay. So now I just multiply them out, and I'm going to go ahead and find, because I'm not dealing with a very big set of things, right? I mean, if I had like lots of branches on this tree and many layers on the tree, then maybe I wouldn't do them all. I would maybe just do the ones I need. But these are kind of as simple as they come. Jacob, got a question?
You put the branches of box A and box B as each 50%. Wouldn't it just be the amount of cards in total there are? So out of 13 cards.
No, because the way I said it was box A is labeled A and contains 8 cards. B is labeled B and contains 5 cards. The box,
So there's just 2 boxes and then
yeah,
just one choice. Okay.
yeah. You pick a box. First we pick a box, and then we select a card out of that box.
Okay.
Cool. So multiplying them out, this is a half and this is a half, so I get 1/4. 1/2 and 1/2 is 1/4. 1/2 and 2/5 is 1/5. 1/2 and 3/5 is 3/10. Now, at this point, it's probably easier to just put it all in decimal, because all of these are terminating decimals. If you didn't have terminating decimals, it would probably just be easier to leave them as fractions and deal with it as a fraction. But you shouldn't be afraid of the fractions anyway. Okay. So find the probability that the card came from box A, given that it's even. So what we want the probability of A given that it's even. So that's the probability of A and even all over the probability of it being even. Okay. So the probability of A and even is this one. And the probability of even, is this one and this one, because, oh, sorry, that's not even. Whoa, wrong one. These two. So I have, that's too damn small. I just didn't want to use up another sheet of paper. And so 0.25 all over 0.45, which is 25 over 45, which is 5/9. Okay. That one work out? All right. Okay. So here's what we have. We have this is kind of a weird question because I kind of don't like asking these kinds of questions, but all right, let's do this one. We have a survey of adults. Well, let's not do adults. Let's just call them, well, let them be adults, whatever. Who visit tanning parlors. Okay. And it shows that 8% of them have skin ailments. Also, 30% of are frequent visitors. Now, just to be internally consistent, because the question was actually talking about a different malady, so I'm just going to say we have a survey of adults. They don't all because some of these people don't visit tanning parlors at all. So we just have a survey of adults. So now we can start asking the question. Okay. So what we have here is a tree, and let's build our tree. Okay. So how many branches on our first split?
Two.
Should be 2.
Okay. You either have skin issues or no skin issues. Now, from here, we have 3 branches because you either are frequent, let's say not frequent, and never. Doesn't really matter what your symbols are, as long as you know what they are and they're consistent. Frequent users, not frequent users, and never. Okay. Take a second, fill in all the numbers. Now, just to make sure everyone knows, what number am I putting down here?
0.92.
Yeah, because you either have skin ailments or you don't, unless you don't have any skin, which in that case you probably have more problems than, you know, whether or not you go to a tanning parlor or not.
So
Okay.
then why didn't you like subtract from like the no skin stuff to put in this top part?
What do you mean?
So like with
Talking about
the
right here?
yeah. So like why didn't you just put 0.7 for no at the top or never?
Okay, so because you either visited frequently, visited infrequently, or never. And of those 3, this has to add up to 100%, right? So the question, like if you're standing in this group, you have a skin issue, but you never go to a tanning parlor. But down here, here you don't have a skin issue and you don't go to tanning parlors. Does that make sense? Okay. So now I have a bunch of questions for you. First
Oh,
question.
yes.
Yeah, aren't you excited? Like, can I have a drum roll? All right. An adult is picked at random. What is the probability that this person this person is a frequent visitor? So before we go into it, let's fill in all of our numbers. Now, depending upon, like if you were on an IB exam, you might not have time to fill in all the numbers, but it might be worth it. Okay. So to find out what this, let's find out what each one of my 6 scenarios is. So I have 0.024. I have 0.048 and 0.008. Okay. And just so that I'm not doing this 3 times. Is 0.046, 0.598, and 0.276. Okay. Did everyone get the same numbers as me? I hope. Good. So, what is the probability that they are a frequent visitor? That means, and think about it this way, all of these green numbers add up to 100%, right? So if I look at, and let's say, I'm doing my survey, and if somebody walks up to me and gives me an answer, yes, I'm a frequent visitor, I'm going to take their application and stick it on the bottom, or so their survey and put it at the bottom. So that means I'm talking about everyone who is here and everyone that's here. So that is or 7% of people. Karam, you rounded and then turned it into a fraction.
Yeah, I just realized that now.
Yeah. Okay. So that's the answer to question A. Are we cool on how I got question A? The answer. Okay. So question B. If the person is found to be a frequent visitor, what is the probability that this person has skin problems? So and just give me your answer with 3 sig figs is fine. Or as a fraction, I don't care. Okay, I got a couple of good answers in there. All right, so let's ask ourselves this thing. If you are a frequent visitor, it's given that you're a frequent visitor. That means that you're in one of these two piles. Okay. So that's the whole group of people that I'm dealing with. So that is my denominator. Now, what's the probability that they have skin problems? Well, that would be these people, because you're frequent and you have skin problems. So you wind up with 24, excuse me, all 0, I'll just put the whole thing in there, all over 0.07, which is approximately 0.343. And this really kind of comes down to the whole idea of it. I've got the probability of you being, you having skin issues and being frequent, all over the probability of being frequent. Okay. And the probability of being frequent was 7%, which came from here anyway. That's my cursive F, everyone, so don't yell at me. Okay. Question C. If a person is found to have skin problems, what's the probability that this person is a frequent visitor? So that's asking a different question. They sound a lot alike. Let me write it down. And there's two ways of solving this problem. Okay. Seeing good answers coming through. Happy, 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 happy. There were two ways of solving this problem. Okay. So if we look at this from a, from the probability standpoint, what you're looking for is you want the probability of somebody being frequent and having skin problems all over the probability of having skin problems. Well, frequent and skin problems is that one. Probability of skin problems is all three of these. And when you do that math, you come up with 0.3. Okay. Now, that's one way. Another way is, given that they have skin issues, means that I am here. What's the probability that they're frequent visitors? 30%. It was given in the problem. So you, whoops, sorry. So you could do it, doing it like the math way, or you could realize that the question was given, the answer was given in the question. Okay.
I feel dumb.
No, no. Well, first of all, it's cool to realize that it worked out both ways. You know, like, let me ask, I mean, how about this? For those of you who got it right, did everyone do it this way?
No.
Jacob, was that you? Yeah. Well, you
I
answered,
just looked at the graph.
right, because you answered within like 5 seconds. And that's why I thought that maybe you had looked at it and saw it from the, here to there, and there's your answer. But some other people probably did it this way, which is totally cool too. And it works out. All right, last question on this tree, which may not have a lot of other time. All right, oh snap, okay. If a person is found to be a non-visitor, what's the probability that they have skin issues? Okay, getting some good answers so far. All my submitted answers are correct. Okay, so let's dig into it. We know that they are non-visitors. They're in that group already. So they're in these two categories, these two clusters. So that's my denominator. Okay. Oh, sorry, I bumped my camera. So I have what's the probability that they have skin issues? Well, skin issues is this guy right here. And that comes out to being 282. Okay. So my question to you is, I'm seeing some answers where some people are like picking the numerator or the denominator, but not putting them over each other. The trick here is to realize what is the group that we're initially the group that we're talking about. Okay. And so if they're non-visitors, that means that they're in these, and that's your denominator. Just like if when we were here, if they're frequent visitors, that means they were in these two groups. And that's what gave me my denominators. Okay. And then you ask the question, what's the probability that of these, if you're in these two groups, do you have skin problems or not? Okay. Another way, just for argument's sake, to deal with this tree is to set it up as a grid. And sometimes the answers are, or the problem is given as a grid. So and I have frequent, not frequent, and not and then non-visitors. Okay. Now, at this point, you know, it's probably easier to find these numbers in here than put them in their different categories. But if we did that, so I've got 0.486, sorry, 0.46, not frequent, and if we go ahead and did this for a second, all right, let's just go ahead and add up these three numbers. And you're going to get 16, 50, 66, 80, 90. Did I make an error? No, it's 8. And when I add up all three of these numbers, adding up these numbers, okay, and that works because you add up these three numbers, you get 100%, and you wind up with 1, which is what you should get. Okay. So if you think about it in this context, if we revisit these questions just for a second in this grid, it might be easier for some people. We'll see. What's the probability that they're a frequent visitor? 7%. Given that they're a frequent visitor, so you're in this column, what's the probability that they have skin problems? Well, total is 7%. And the one I want is this one. And that's exactly what we wound up doing here. Okay. Given that they have skin issues, so you're somewhere in this category, what's the probability that they're frequent visitors? Well, that would be this divided by all of them added up, or that. And that's exactly what we did. And then finally, the last one was if the person is a non-visitor, so we're in this column, what's the probability that they have skin issues? So it's this over all of them, or 0.284. Okay, so does that hopefully make a little bit more sense? I hope. Maybe that thumbs up if that was helpful. Okay, great. Thank you so much for making me feel like I just wasted 5 minutes. Oh, no, it's okay. Okay, so anyway, all right. My question to you is, on a scale of 1 to 5, how do we feel about this? Put it in the private chat. And I really want everyone to answer. Yeah, a lot of it has to do with wording. Okay. All right. So I have one document that I'm gonna. They decided for some stupid reason, I guess, to not allow teachers to send files through Zoom. So I'm gonna have to email it to you, which is such a drag. I'll do that right now. Just so that everyone has it. Everyone can. I'm not gonna send it to your parents like I did that time. That was funny. It was dumb, but it was funny. All right. The hell? This has got to change. Oh my gosh. All right. Sorry, this is taking so long, ladies and gentlemen. All right, I will see everyone later. I'm going to get this email out to you as quickly as I can, and it will be in your inbox in a matter of a few minutes.
Thank you. Have a good day, Mr. Ronco.
You too.
Bye. Thank
See you
you.
later.
Yeah.
You have a good one.
Have a good one.
Oh, you're kidding me.